These 5 examples are going to be the equations I'll solve on this lecture. The first 3 that have a t beside them I will also be doing in separate videos using algebra tiles. So take a look at both. So with the first one, solve 3x plus 2 equals 11. Well, if I were evaluating this, pick a number for x, plug it in, I would take that value of x, I'm going to multiply it by 3, and then I'm going to add 2 to it. So the multiplication is first, the addition is second by order of operations. If you're getting dressed, you put on socks, you put on shoes. You can't take your socks off unless you've taken your shoes off first. You have to undo in reverse order. So, same thing's going to be true here. Addition was the last thing I did to my variable. It's going to be the first thing I have to undo. Right? So, I've got variables all on the left. The first thing I need to do then, the plus 2 was added. That's the last thing that was done, so it's the first thing I have to undo. So 3x plus 2 equals 11. I'm just recopying. And then I'm going to subtract 2 from both sides. Sometimes using another color to show what you're doing can be useful. That also prevents you from only subtracting on one side. If you don't see the other color on both sides, you haven't done the same thing to both sides, and you've therefore changed your equation. Plus 2 minus 2 is 0, so I'm just left with 3x. 11 minus 2 is 9. So now I've got the equation 3x equals 9. To get x by itself, I need to get rid of the 3. The 3 is stuck with the x by multiplication, so to undo multiplication, we divide. I'm going to divide both sides by 3, because again, I want the x by itself. I want the coefficient to be 1. 3 over 3 just gives me x, and 9 divided by 3 gives me 3. X equals 3. Now, it's always a good idea to check your work. If I think that x is 3, well, I know if I plug it into the equation, 3x plus 2 equals 11, and I'm saying that x is 3, if this is a true statement, then I know that 3 is the correct solution. And I'm not going to actually work the check for most of these, but here, not hard. 9 plus 2, 11 equals 11, is a true statement, so we do feel very confident. We know that x equals 3 is our solution. Now, you can either write x equals 3, or you can use set notation. These are braces, and I can say my solution set is the set containing the number 3. Use whichever notation you're told to use, but either can be acceptable. Here, we've got variables on both sides of the equation. So the first thing I need to do is be sure I get my variables all onto one side. So move your variables first. It doesn't matter whether I get them all to the left or all to the right. I've got them both sides. For this one, I'm going to move to the left. You will get the same answer if you had moved to the right. 3x minus 1 is 5x plus 7. So I want to get rid of this 5x. It is a positive 5x, so to undo addition, I subtract. So I'll subtract 5x on both sides. On the left, 3x minus 5x is negative 2x, and then that minus 1 is still there. On the right, 5x minus 5x is 0, and I'm simply left with the 7. So I need x by itself. All the x's are on one side. Well, the last thing I would have done to my variable is subtracting 1, order of operations. Addition, subtraction is the last thing you do. So that's the first thing I undo. Again, I have to take off shoes before I can take off socks. So I have negative 2x minus 1 equals 7. To get rid of the subtract 1, I'm going to add 1. Do that again to both sides. Showing with color can be helpful. Negative 2x minus 1 plus 1 is 0. 7 plus 1 is 8. To get x by itself, I need to get rid of the negative 2. The negative 2 is stuck with the x by multiplication. To undo multiplication, I divide. I'm going to divide by negative 2. Negative 2 divided by negative 2, same sign, answer is positive 1. X is 8 divided by negative 2, negative 4. With the check back in the original before anything was done, 3 times x minus 1 is 5 times x plus 7. I claim that x is negative 4. Again, be sure you're using parentheses. I'm not going to show the check. If you do it on your own, though, you will get that negative 13 equals negative 13, a true statement. So x equals negative 4 is the solution. Here, variables on both sides of the equation. Well, 4x plus 2 equals 3x. I could move my variables to the left or to the right. In this case, what's going to work best is going to be to move the variables to the right. Because if I move the variables to the left, I'm going to end up having extra steps I have to do here. So 4x plus 2 equals 3x, because the only thing I have over here is my variable. So I'll move all my variable terms to the right. I want to get rid of the 4x. It's a positive 4x, so to undo, I'm going to subtract 4x on both sides. 4x minus 4x is 0. I'm left with 2 on the left. On the right, 3x minus 4x. I have 3 I owe 4. That's negative 1x. I need to get rid of the negative 1 because I want the x by itself. The negative 1 is stuck with the x with multiplication. To undo multiplication, we divide. Dividing both sides by negative 1, I have negative 2 equals x. With a check, 4x plus 2 equals 3x. I'm claiming x is negative 2. If I do that check, it's going to work out to get the true statement that negative 6 equals negative 6. X equals negative 2 is the solution. And I do encourage you to do the addition subtraction on both sides and at the end of the line. I don't encourage students to do addition or subtraction underneath the problem because I've seen too many errors when they make careless mistakes. If you have any questions about that, feel free to toss me an email. So here, variables on both sides of the equation. I need to collect all my variables on one side. It's not going to matter which side I move them to because I've got constants on both sides as well. 5x minus 6 is 9 minus x. I think I'll move my variables to the left because I've got more x's on the left. I want to get rid of the negative x. To undo subtraction, I add. So I'm going to add x to both sides. 5x plus 1x is 6x. The minus 6 is still there. Equals 9 minus x plus x is 0. At this point, undo the thing that was done last, so I need to get rid of the negative 6. To get rid of a negative 6, I add 6. Same on both sides. 6x minus 6 plus 6 is 0. 9 plus 6 is 15. To get x by itself, get rid of what's stuck with it. The 6 is stuck by multiplication. Undo multiplication by division. 6 over 6 is 1. Now 15 over 6, there's a common factor of 3. 15 is 3 times 5. 6 is 3 times 2, so we can divide out that common factor, and we're left with x equals 5 halves. You do not want to go to the mixed number of 2 1/2 unless you've got a word problem, and you would only go to the decimal form 2.5 if you have a word problem and you're dealing with something that we measure in decimals like money. Otherwise, 5 halves is the preferred form. It is a rational number. That makes checking easier. 5x minus 6 is 9 minus x. I claim that x is 5 halves. When I do that check, I'm going to get 13 halves is equal to 13 halves, a true statement, so we know that x equals 5 halves is the solution. Finally, 4 minus 3 times 2x minus 5 equals 19 minus x. Now, this is the equation that we had checked earlier, and so we saw that 8 was not a solution. You'd get 8 if you make a particular error in solving this equation. This is why the check is so important, because if you don't do the check, if you make that mistake when you're solving this equation, you're not going to know that you made a mistake. And that's also why the check needs to be done using only order of operations. So, first step, we've got parentheses. I need to be sure each side is simplified before I go any further. I'm going to need to distribute that negative 3. Multiplication comes before addition subtraction. So the 4 comes down. Negative 3 times 2x is negative 6x. Negative 3 times negative 5 is positive 15. On the right, no parentheses, no like terms, just 19 minus x. On the left, combining like terms, I'll have my negative 6x. Like terms are 4 and 15, so plus 19 equals 19 minus x. Variables are on both sides. I want to collect all my variables on one side. Does not matter which side you move it to because I've got constants on both sides as well. I'll move to the right to get rid of the negative 6x. I'll add 6x, doing the same thing on both sides. Negative 6x plus 6x is 0. I just have 19 on the left. Negative 1x, you can always write the coefficient if it helps, plus 6x is 5x. And then I have my plus 19. On the right, I need to get rid of my constant term now. That's the last thing that I did to my variable. So to get rid of the plus 19, I need to subtract 19 on both sides. 19 minus 19 is 0. 0 is a perfectly fine number. Be sure you write it down. On the right, I have 5x. Plus 19 minus 19 is 0. The reason I won't write that plus 0 on the right is because I have something else there. To get my variable by itself, I need to get rid of the 5. 5 is stuck with the x by multiplication. We undo multiplication by division. 0 divided by 5, does that make sense? Well, I can have a pie cut into 5 pieces and have none of them. It does make sense. It's a sad situation, though. So x is 0. In doing the check, and I strongly encourage you to do this check by yourself, 4 minus 3 times 2x minus 5 is 19 minus x. And I'm claiming that x is 0. Use order of operations, just like in the other video where we checked this with 8. You will get the true statement that 19 equals 19, So x equals 0, the number we evaluated, is a solution of that equation.